Hello everyone, this is Additional Mathematics Form 4 at Maths textbook question for Chapter 9, Solution of Triangle Mastery Practice. My name is Terry. If you enjoyed this video, can you like, subscribe, or leave us a comment? So let's get started. So the first question is involving sine rule and cosine rule. So you're given the angle ABC, BAC, and length of side C. So for me, when I look at this, I would just draw a triangle and just, without labeling the angle, I start by drawing a random triangle with 3 different lengths. Then I look at which angle is the largest. Or you can see that the largest angle is 72. Maybe I put 72 here. And the second one is 50. Maybe I put 50 here. And therefore, B will be here. A will be here. And C will be on top, right? And you notice that the length of side C is 5.2, so we can put 5.8 there. We can put 5.8 cm here, and we can actually find this angle, right? But we're finding for length of A. Length of A is opposite to angle A, which is the length of BC. First, let's find angle C. Angle C is BCA, which is what? 180 minus 50 minus 72. This will give us 58, right? So what happened is the same. This is 58, whereas the opposite length is 5.8. So if you're finding angle, the length of side A, we have to divide by sine 72. Then we take length of side 5.8, divide by sine 58. Now use your calculator. 5.8 divided sine 58 times sine 72. You will get 6.504 cm. Okay, for length of side B, I think better rub this off. Too many lines, a bit confusing. So I'm finding the opposite length here. B will be basically length of AC. So B over sine 50. This ratio must be the same as 5.8 divided by sine 58. Again, use your calculator. 5.8 divided by sine 58 times sine 50. I've got 5.239 cm. Alright, this is part A. Now part B, again, I'm going to draw out the same triangle, something like this, right, with 3 different lengths. And if you look at the 3 length of side given here, right, we have 8.2, 6.56, and 3.63. So 3.63 is the shortest. The opposite length should be R, because this is R, length of side R. The opposite angle here, capital R, should be on the opposite side. Alright, next one will be 6. Now, which one looks shorter? 6.56 here. This will be Q. And the third one will be 8.28. This one looks the longest. This is angle P. So if you want to find angle for each one, we have to use cosine rule, because cosine rule, if you're given length of 3 sides, we can actually use the second version. Now, for those who are not sure about this, the basic formula for cosine rule is A squared equals to B squared plus C squared minus 2BC cos of angle A. Now, for me, I like to rearrange it. I make cos A as a subject. Yeah, maybe I write here, cos A equals to B squared plus C squared minus A squared over 2BC. So it's much easier, so that we can just substitute the value of the length of each side, and immediately we can find the angle. So if you're looking for angle B, your opposite side, which in this case is A, is 8.28. The other 2 adjacent sides will be B and C, which is 3.63 and 6.56. So I'm going to write cos angle B as 3.63 square. This is your B, this is your C, 6.56 square. Your opposite side A, 8.28 square, divide to B, C, 6.56. Use your calculator. Yep, whatever you get, shift cos. I've got 105.03. Now repeat this for angle Q and R. So we write cos angle Q. Now for angle Q, your opposite length is now 6.56. Yeah, so we'll take the other two sides, 3.63 8.28 square minus 6.56 square over 2 3.63 8.28. Again, use your calculator. You should get 49.92. Okay, the third one, I'm finding angle R. R is opposite to this 3.63. Let me just draw an arrow for you to see. So we take the other two sides will be 6.56 square plus 8.28 square minus the opposite line 3.63 square over 2 6.56 8.28. Yeah, use your calculator. Angle R is 25.05. All right, that is for number 1. Let's move on to number 2. Okay, this diagram looks very small. I will zoom in for you. Okay, so the first part we have to use sine rule. Now maybe I find this angle first. Let's find angle XYZ, which is 180 minus 55 degree 13 minutes. You can use your calculator. Yeah, this will be 124 degree 47 minutes. Remember, 1 degree is 60 minutes. So yeah, you can convert to 179 degrees 60 minutes, and then you minus 60 with 13, you get 47. Yeah, 169 minus 55 is 124. Sorry, 179 minus 55, 124. Okay, I've got this as 124, 47. To find this angle X, or we say YXZ, is now 180 minus 124, 47 minus 31. This is 31 degree and 52 minutes. This will give us 23 degree 21 minutes. 23 degree 21 minutes. Okay, what we are finding is the length of side X. Now X is opposite to this angle 23. You see, 23 21. So we can write X divided by sine 23 21 equals to the opposite length is 14 divided by sine 124 47. Now use your calculator. My X is 6.756. Okay, I think this is still okay, not difficult. Okay, B, we have to use cyclic quadrilateral. The concept that you learned in Form 3, we know that when you have 4 points on the edges, on the circumference of the circle, yeah, this is called a cyclic quadrilateral. With the opposite length here, angle here 77 is opposite to angle P, and P will be 180 minus 77. The relationship between them, if you add up, is 180. We call it interior opposite angle. So SPQ is 180 minus 77. I got 103. Okay, so once you get this angle, it's very simple really, because we know the length of 2 adjacent sides. We know the included angle. We have to use cosine rule. So x squared is now 3 square plus 6 square minus 2, 3, 6 cos 103. You use your calculator, square this whole thing, 7.287. Okay, yeah, I think this is still okay, fairly simple. All right, moving on to question number 3. Now I must say question number 3 has nothing to do with solution of triangle, no sine rule, no cosine rule, even area triangle, because this is something that you can actually use, something that you learn from 1 half times base times height and Pythagoras theorem to solve it, right? The first thing is we want to find the length of AC. As you can see, before you find AC, you need to find BC. BC, I can take 10 square minus 3 square is 3. Yeah? 10 square minus 3 square square root of 91. Yeah, this length is square root 91. Now the length from A to B is now 10. So to find AC, I'll take 10 square plus square root 91 bracket square. Since AC is the longer side, we have to plus. In this case, is square root 191. Now if you use a calculator, square root 191 is going to give us 13.820. All right. And to find area of triangle ADC, yeah, I need to highlight to you guys this, because a lot of times you're familiar with area of triangle where the triangle is an acute angle. If it's an acute angle like this, this is your base, this is your height. If it's a right angle, this is your base, this is your height. If it's an obtuse angle, this is your base, and your height actually fall outside your triangle. Now in this case, the triangle that you're finding is this. Can you see? ADC. And what is your height? Your height is actually square root 91. And the length of your base is actually 7. You just have to like rotate it. Just have to rotate it 90 degrees. Take this triangle, rotate it. You can see the shape there. So my area of triangle ADC is just half times 7 times square root 91. Yep, I got 33.388. But I think the answer given is 33.387. Doesn't matter. I think because the textbook they round off square root 91, so that's why the answer is a little bit different, but that's fine. Now this is actually more accurate because I use the exact value square root 91 instead of leaving it in decimal. Alright, moving on to question number 4. Okay, now so this is the case involving ambiguous or ambiguity. So number 1, I would draw angle x42. Let me draw something like this, right? 42 is around here, right? This looks like 45. Yeah, it doesn't matter. 42.2. Now let's say I call this angle x. The opposite side x is 10, and z is the opposite length. Z would be opposite length is 13.4. So up to you how you want to draw it. Maybe I draw like this, and I would put angle z here, so that the opposite z will be 13.4. It must look as though that it is longer than this opposite side of x, which is 10, right? It must be longer. All right, so now that I've done this, I've drawn this, so this is only one possible triangle, right? Now I hope you know that for ambiguity to exist, the opposite side of a given angle must be shorter than another given side. Another given side in this case is 13.4. Okay, so that's number 1. Number 2, these two given sides will meet at a point. That point is y. So y behaves like a hinge, right? That you can actually flip either inside or outside, right? So in this case, I have to flip inside. I can't flip outside, because when you flip outside, this line will never meet line xz again. Yeah, even if I extend xz, it will never meet again. So what I have to do is I have to flip it inside like this. Can you see? Such that this length is about the same as length of yz, which is 10 cm, right? So I'm going to draw the second version. Okay, I'm going to draw a second version over here. So it looks like this, right? This is x, z, y. This is about the same length, 10 cm. This is still 13.4 cm, doesn't change, and this angle is 42.2. So this is the two possible shape of the triangle that we can get, right? Okay, second one, find the possible angle for z. Now when it comes to ambiguous, then you know that you have two possible different angle. We have to use sine rule. The first angle for z, I could take sine z divided by 13.4. The other pair will be sine 42.2 divided by 10. So when you want to find z, you realize that when you take a calculator, sine 42 over 10 times 13.4, you will get one answer, 64.17. But this is not the only answer. This is the first answer, 64.17, right? Now notice that if you flip this in, let me just highlight this for a while. Use a green pen here, draw another line here. Now if these two are equal length, this is also 63.17 because they are isosceles triangle. So the angle next to it, right, which is the same as this angle xzy, perhaps I should label this as prime so that you can see there's two different triangles. The first one is without prime, second with prime. So the second z prime will be 180 minus 64.17, and that will give us 115.83. Yeah, hope it makes sense to you, right? So one is acute, one is obtuse. C, calculate area of triangle xzy for the obtuse angle of z. Now obtuse angle means we're taking the second one. Okay, so we already know this is 115.83. To find area of triangle, I need this angle because I have the length of two sides. I just need the included angle. Included angle is angle in between two given sides. So angle y prime in this case is 180 minus 42.2 minus 115.83. This will give us 21.97. And by using the formula for area, half AB sine C, 13.4 only, sine C, C will be 21.97. I got 25.066. Okay. Moving on. Question number 5. Okay, the diagram on the right shows 5 points A, B, C, D, E, which forms quadrilateral. BCD is a straight line, ACD is obtuse, ACB is obtuse, okay? And area triangle ADE is 20. So this is 20 square cm. So it's first find the length of AD. Okay, to find the length of AD, now in this case you might have to use two-step, because if you focus on triangle ACD, you can't really find it. You can't find even from triangle ADE. So you may have to start from triangle ABC. Okay, so let's focus on triangle ABC. Okay, let me just redraw one triangle so you can focus one at a time. So this is triangle ABC. This is 5 cm. This is 30. This is 9. So we need to find one angle here. Yeah, focus on what we can find. We can find angle C. So I'm going to write sine angle ACB, divide by 9. This is sine 30, divide by 5. And we know this is obtuse. So angle ACB is obtuse. So when you use your calculator, you should get 64.16, but we need to take 180 minus, right? And this will be 115.84. Now, if I know this is 115.84, I can find the angle next to it. The angle next to it is ACD, which is 180 minus this. Don't have to calculate because it's just here, 64.16. If this is 64.16, we can now find the opposite side, AD. Yeah, maybe I draw one more for you. Yeah, let me draw nicely. Okay, it looks like this. This is ACD. I know 5, I know 6, I know 64.16. I can find the length of AD. And AD, if I square it using cosine ruler, 5 square, 6 square, 2, 5, 6, cos 64.16. Now use your calculator. AD is 5.903. Okay, lastly, if I know length of AD, now let's focus on the third triangle. Yeah, this triangle ADE, I know the length is 10. I know AD is now 5.903. I know the area is 20. And I'm finding angle DAE, this angle. So we can use the formula for area triangle. Half AB, my A will be 10, B is 5.903. Doesn't matter whichever comes first. A can be 5.903. Sine of the angle in between, DAE, is now 20. So let's find DAE. Use your calculator. 20 times 2 divide 10 divide 5.903 equals whatever you get, shift sign, answer. I got 42.66. Alright. Okay, let's move on. Question number 6. Okay, now this one is a little bit challenging, a little bit. Right, you have a base of an equilateral triangle, yeah, with a length of side of 6 cm, and it lies on the horizontal plane. So let's draw out the base. It looks like this. This is triangle PQR. Equilateral means all must be 60 degrees, right? Okay, then they say point T is 4 cm vertically above midpoint of PQ. So now here's the thing, we need to let the midpoint of PQ be another symbol, say M, right? This one must be perpendicular. Sorry, right? My line is not very straight, right? Not very accurate. So it looks like this. Now let's find, we're finding the angle formed by TR and triangle PQR. Now TR is a line. I don't know whether you know this. Angle between a line and plane is, let's say, let me draw another one. It looks a bit hard to see, right? So this is T, this is M. Okay, so your line R is over here, right? If you shine a light bulb downwards, the shadow of TR will fall onto here, long line MR. So angle between a line and a plane is what we call the angle between the line and is orthogonal projection. In layman's term, we say the shadow of line TR will fall on line MR, where M is the midpoint of PQ, where T is perpendicular above M. So this is 90 degrees here as well, right? So I need to find the length of MR, then find the angle between TR and MR, and T is 4 cm vertically above M. So let's start by finding MR. Now I'm going to rub this off later. So MR, you can use any Pythagoras theorem or even SOHCAHTOA. We know that M is a midpoint, so this is 3. Yeah, the whole thing is equilateral, so half of 6 is 3. We'll take 6 square minus 3 square square root. This is square root of 27. Alright, so then I'm going to draw this shape here. I'm going to draw T, this is M, this is R. Right, I know MR is square root 27. I know T is 4 cm vertically above M. And to find the angle between line TR and the plane PQR, that means we are finding angle TRM. We can just call this theta. So here I use tangent, theta is 4 over square root 21. I don't have to use cosine rule or sine rule. Just use SOHCAHTOA shift tangent 4 over root 27. I got 37. Sorry, this is 37. 37.59. Okay. Now this used to be in Mod Maths Kssm syllabus, but they removed this already. So I know a lot of students, they don't have proper what they call that in-depth practice on the concept of line, angle between a line and a plane. Okay, let's move on to B. How do you find area of plane TPR? Okay, TPR is on the other side. It's a slanting plane. Before you find the slanting plane, let's just focus on the vertical plane. Vertical plane PTQ, because PTQ is perpendicular to the base PQR. PQR is on the surface, PTQ is here, it's perpendicular here. I hope you know. I just draw this out so that I can find area PTQ, TPR. To find TPR, I need to find TP, yeah, and I need to find TR. Okay, so let's find PT first. Okay, we know that if I draw this down, this is your M, right? PM is 3. PT, I do not know what is the length, but I do know TM is 4 cm above M. So from here it's very simple. PT is 3 square, 4 square, square root. You don't even have to count this. We know it's 5, right? PT is 5 cm. Alright, so now that I know PT is 5, oops, use the wrong tool, supposed to be use pencil, this is 5. Okay, I want to draw out, I need to draw this PTR out, but the problem is I do not know what is the length of TR. I really can find TR from here. So TR is 4 square plus square root 27 square root, yeah, we find from the triangle. So it's 16 plus 27 square root 43. Now I'm going to draw the slanting plane PTR because I need to find the area. So this is my slanting plane PTR. I know TR is square root 43. I know 43. I know PR is 6 cm. I know PT is 5 cm. Now here we can use cosine rule to find angle, then find the area by using half AB sine C, or you can use Heron's law. Now since we already learned Heron's law, so most of the time, if I'm not given the length, any angle, I'm given length of 3 sides, I just use Heron's law. I wouldn't say it's faster, right? I think it's about the same as using as finding the angle first. So we'll just do this, okay? 5 plus 6 plus square root 43 divided by 2. I got 8.7787. Okay, here's the problem. I need a lot of space for the next one. Okay, so usually Heron's law takes up a lot of space for the area, right? So the formula works like this. We take your semi-perimeter, 8.7787. Okay, sorry for those who didn't know about this. This semi-perimeter S is the sum of all three sides, the perimeter, call it, you divide by 2. And we take this value, you multiply with the difference with the first length, 8.7787, with the second length, 8.7787, with the third length, square root 43. And whatever you get, put the square root over, right, you should get an answer 14.309. Okay, so you notice that I use a lot more decimal. Normally we want to find answer correct to 3 decimal places, but this is 4. I use 4 so that it enhances the accuracy of your final answer. I use 4 for the semi-perimeter. All right, that's for number 6. Let's move on to number 7. Okay, number 7. All right, okay. I need to zoom this out. Yeah, not enough space. All right, a group of Girl Scouts. Okay, they took part in camping, right? So they set 10, the 3 position given. So you want to find obtuse angle of ACB. They already mentioned this ACB is obtuse, so we can use sine rule. Sine angle ACB divide 8, sine 50 divide 7. ACB will be, now when you use your calculator, you get 61.1, but you need to do 180 minus, because the question already mentions obtuse. Yeah, so this will be 118.90. Okay, part B. They say, draw and label another triangle other than triangle ABC here, which shows the possible position of C such that distance AB, distance AC, and angle ABC are maintained. Now, so this is the case of ambiguity, and remember, ambiguity happens when the opposite side, which is 9 AC here, of a given angle, my angle is ABC, is shorter than another given side, right? The other given side is 8 cm, AB. So the thing is, yes, we know the ambiguity exists because AC is shorter than AB, right? The opposite side of a given angle is shorter than another given side. The second thing is the 2 length of side here, maybe I highlight for you, the 2 length of side here, they meet at point A. So A is a hinge, yeah? So you're going to take A, you're going to flip it either inside or outside. Now, obviously, I cannot flip inside. I flip inside, it will never meet line BC again. So if it doesn't meet line BC, then, you know, it looks like this. You flip it this way. Use a compass if you need to, right? If it doesn't meet line BC again, then this angle B cannot be maintained. So it actually lies on the extended line of BC. So C prime is over here. So we're going to draw a second triangle. So yeah, the question asks you to draw and label. So I'm just going to maintain the shape, maintain the size. Oops, my line is a bit ugly. Sorry, please use a ruler. Yeah, I just use freehand. Yeah, so this is A, this is your C prime, and this is your B, and you need to show yeah, they say draw and label in a triangle, show possible position of 10C. So C can also be here, and these two must be equal length. Well, I know this is 8 cm, 8 meter, but BC, this is 7 meter, but C prime is not, so we don't know. I'll just label this like this. Okay, so I think my triangle is complete. Yeah, that's all. Okay, the next part, let's rub this off, because part C is not related to part B. Yeah, you are given 10C has to be relocated to another position, but the distance between 10A and B, AB remains the same. Angle BAC, this angle 50 remains the same. You're calculating angle, the length, distance AC, such that only one triangle can be formed. Okay, so let's say if I want to maintain this shape. It's very interesting, very interesting question. So, okay, let me draw a bit higher, slant a bit higher. All right, so this is your triangle BC. Okay, it doesn't look very good, but never mind. This is A, C, B. I want to maintain this length, right? This angle I need to maintain. Okay, so now you understand that again, ambiguity can exist. That is, I can draw another triangle with the same measurement, but provided the opposite side BC must be shorter than the given side AB. Yeah, in this case, which is true. So you may want to focus on these two lines again, like the concept I taught you. These two lines, they actually meet at point B. So if you have a compass, you take a sharp end of a compass, put here, and then, okay, this is your pencil, I know how to draw it. All right, you put the sharp end here, put the pencil over here, and you draw an arc like this. So when you draw an arc like this, you can see that the arc will actually meet here, extended line AC here. So there are two possible triangles that we can form, right? Now you will always have two possible triangles, yeah, while maintaining the length of BC, if you were to maintain the length of BC. But there's one case that you only have one triangle. How can you have only one possible triangle? If, okay, for example, let's say better rub this off. If I shorten my BC, okay, let me just give it a scenario. I shorten my BC. What happens is my BC will be here. So I can have another triangle, right? Two triangles as well. Yeah, I still have ambiguity, right? But what if I draw B, C exactly here at a 90 degree? So at a 90 degree, I can only have one possible value for C, right? One possible position for C. There's only one triangle can be formed. I can't form two triangles, right? So in that case, I'm going to redraw this triangle for you. So I'm going to draw like this. Okay, this is A, this is still 50, this is B, C can only be here, so that you only have one triangle, right? So, and to find the length of AC, since we have a right angle triangle, don't need cosine rule, don't need sine rule, just use SOHCAHTOA. In this case, cos 50 is AC over 8. AC is 8 times cos 50. I got 5.142 cm. Okay. Yes. All right, next one. Okay, this question is very similar to SPM 2003 question. I've seen it before. I've done many times with my student. All right, so the first thing we need to do, I need more space. I need to make it smaller, slightly smaller. Okay, now you have a glass block in the shape of a pyramid VABC. You're given the measurement, blah blah blah. So they say the angle between the inclined plane and the base is 30. So calculate angle BAC, given that base area is 8.69. So now it's hard to imagine when this is 3 dimensions. So I like to break it down to part by part. I look at the base first. My base is a triangle ABC. So I'm drawing out the base. So this is your base, right? This is C, A, B, and you are supposed to find the angle BAC. So we know these two, they have the length of AB and AC are equal. They are isosceles 5.2 each, and we know the area is 8.69. So I'm going to use half AB sine C. Since your AB, they are equal 5.2, so I just take 5.2 square sine angle CAB, and this result is 8.69. So angle CAB will be what? Take a calculator, 8.69 times 2 divide by 5.2 square. Whatever you get, shift sign, your angle is 40, right? Okay. Now the next thing is you're supposed to find the length of AV, yeah, given the angle between line AV and base is 25. Okay, now first of all, I would draw out this VA, this triangle here. Can you see this triangle here? Right? Now to find angle between a line and a plane, so the line and the plane, in the previous example I did mention, let's say if you want to know, like this is line, okay, my line is still a bit ugly looking, a bit chat, sorry. Oh, never mind, can't draw a perfect line. So okay, I need to draw bigger so that you can see clearer. So when you talk about angle, this is A, B, C. Alright, V is on top. So angle between a line and a plane. Your plane is ABC. Yeah, number one, you need to imagine there's a light bulb, you shine downwards. The shadow of V will fall onto here. Not very clear, right? And the whole line will be here. It will be right in between, right? Okay, and if you were to extend this line, it's going to meet the midpoint of BC, let's call it M. So this angle is given as 20, right? This angle is 20, right? So I'm going to draw another version here. Yeah, I'll explain first, later I'm going to erase this. So this doesn't look 20. This angle is 20. All right, so this is A, this is V, and let's say this is my B. Okay, now at the same time, earlier they already given us angle between inclined plane VBC and base ABC is 50. Okay, now when it comes to angle between two planes, again I said this earlier, I said that you don't really have a lot of practice on angle between plane and plane, line and plane, right? Because it used to be in the ModNet syllabus, so students are expected to know this is SPM 1993 style, sorry, 2003 style question back then. So if you want to find angle between two planes, number one, you got to identify the intersecting line. Now they say VBC and ABC. The common letter is BC, so they both intersect here. Oops, I used the wrong tool. Let me use red pen. They intersect here. So then I'm going to draw a 90 degree to each plane. So the first plane, ABC, is here, 90 degree to the first plane. And the second 90 degree to the second plane. Second plane is BBC. So this line, they are perpendicular to the red line. The red line is the intersecting line. Number one, we identify the intersecting line. Number two, we draw perpendicular line to each plane. Number three, if you were to close these two, yeah, if I take this plane VBC and plane ABC, I just close them together, the two blue lines will overlap. And the angle made by these two blue lines is here, 50, right? So I'm going to draw on label 50 here. All right, so up to here, okay. Now, what else do we have? We have, because we want to find length of AV here, we have the length of AM. Sorry, I think I should write this as M. This is not B, this is M, because M is a midpoint. So I'm drawing the line here. You see, this is M, M is a midpoint. So I can extend the base here, this is M, and find the length of AM from the base. We know this is 20 already, right? The whole thing is 40. CAB is 40. Half of it is 20. So we can say AM is 5.2 square minus, we can use Pythagoras, right? No, you don't use Pythagoras. Use SOHCAHTOA, use cos. Cos 20 is AM divide 5.2. AM, right? My AM is 4.8864. Now I'm thinking I should use 4 significant figure. I mean, yeah, but it's better to use more. I'm just in case. 4.8864. So I've got AM already. So this is 4.8864, right? So I want to find AV. Now here's the thing. And just to let you know, I personally think this question is a bit off, because actually 20 degrees shouldn't be given, because if you draw the side here, this is VBC and this is M. We know VB is 3 cm. BM we can actually find, right? And if you work out BM, right, and then you find your VM, you will get different answer from here, slightly different answer. It's not exactly the same, right? So, but I just thought, since you're given already, so I don't want to go and calculate from another point of view, right? Because if this is a right angle triangle, it's just like how we calculate the base. We can actually find VM, and we don't need the 20 degrees. But if you count VM, your answer is a little bit different. Yeah, not a little bit. It's quite different, right? So anyhow, I'll just proceed with what I have, right? So you type in your calculator earlier, right? Cos 20, you times it 5.2. I got 4.8864, so this is correct. Now, with all this information, I can find this angle AVB, and AVM, angle AVM is 180 minus 50 minus 20. This is just okay. Sorry, I think this is 25, not 20. Yeah, sorry, I wrote this wrongly. This is not 25, not 20. Yeah, so minus 25. Yeah, can you see? Yeah, this is 25. Okay, so this will give us 105, and if this is 105, we can now find AV by using sine rule, right? Sine AV first. AV divided by sine 50. I'm going to use 4.8864 divided by sine 105. My AV is 3.875. Okay, yeah. Now, next one. Find the surface area of VAB. Yeah? Now, VAB is this side, the slanting surface, but to find that, I need to know the length of, I got AV already, I got AB already, I got VB, oh, I got all three. So this is a slanting surface. It looks like this, A, V, B. This is 3, this is 5.2, AB is 5.2, VB is 3, is also given, right? And AV I've already got from here 3.875. So this is where we can use Heron's law. So take semi-perimeter, so 3 plus 3.875 plus 5.2 divided by 2, I got 6.0375. Okay, another problem, I can't fit this thing in. So how do I fit it in? A equals to 6.0375 multiply 6.0375, you need to minus 3, 6.0375, you need to minus 3.875, and last one 6.0375 minus 5.2. Sorry, very, very small. You need to squeeze it in. Put the square root over. There you go. Answer is 5.763 cm. Okay, can? Next one. All right. So Rashid drove a boat westward. He noticed a lighthouse at a distance of 25 km away at a bearing 235. Sketch a diagram to illustrate the situation. Okay, so now I'll draw a line like this. Okay, a horizontal line. He's supposed to travel west. Okay, I need to show you. My line is not straight at all. So this is north, right? So bearing of 235, it should be like this, right? How long, how short is up to you. So this is 235. We know if you extend this line, this angle should be 55, right? And this angle over here should be 35. So there is a lighthouse over here, right? So the lighthouse is 25 km away from the place you start, right? Now, you're supposed to sketch a diagram. I suggest you read the whole question before you draw the diagram, because when you read diagram part A, it's quite kind of limited information, right? You don't know how far you drive, you know that lighthouse is 25 km away. All right, so you read the whole question. They say, what is the distance travel when it's 16 km? Okay, 16 km. Then read the whole thing. He continued to drive until it reaches 16 km again. So that means this is a case of ambiguity. Now we have two positions, right, with 16 km. All right, so this is 16 km. But I'm not going to put this in my diagram, yeah, because partly asked you to draw, but we don't know the position yet actually. So you can actually draw without this, but I will still need the diagram for part B and C, right? So okay, I think I'll just leave it. This is your boat. Now, because you have two different positions, I'm going to call it B prime, and let's say the starting point is A, right? So if you just read the first line, you probably wouldn't know how long you should draw this, right? I mean, you probably can draw like this, you know, or like this, or like this. So we wouldn't know it's actually acute angle or obtuse angle or even right angle, right? So I just draw the whole thing after reading the whole question. All right, what is the distance travel, yeah, when it is 16 kilometer from the boat? Is 16 kilometer from the lighthouse. So, okay, number one, I will know all this angle, right? I know this is 55, 35. I hope you know why it's 35. Right? West means going to the left, the angle is 270. You can say 270 minus 235, you get 35. Okay, so I want to find the distance AB. But before we find distance, let's look at what we have. We have angle, opposite length. And we have opposite length, we need to find this angle first. We need to find angle B. So this angle B is an obtuse angle. Now again, if you don't read the whole question, you wouldn't know that this is obtuse. Yeah, you probably think it's acute, right? So my part A is done. Let's look at part B. I'm going to write sine angle LBA divide 25 equals sine 35 divide 60. And since I know it's obtuse angle, I'll take 180 minus whatever I get here, which is 63.66. I got 116.34, right? So 116.34. Okay, with this I can find this angle here. Angle L, sorry, it should be BLA. BLA, yeah, which is 180 minus 116.34 minus 35. I've got 28.66. If I know this 28.66, I can find the distance AB. Distance AB represents the distance that you travel, right, before you're 16 kilometers away from the lighthouse. So I'm going to write AB. You can use cosine rule actually, or sine rule. I think sine rule is easier. AB divided by sine 28.66 equals to, I'll take 16 divided by sine 35. My AB is 13.379. But you know, there's one problem with the textbook, the consistency. Sometimes they give 3 SF, sometimes they give 4 SF, sometimes they give 3 decimal, right? So you notice this time, answer given in the textbook is 13.38. So I just write 13.38. Okay, C. Calculate the distance between the first position and the second position. That means finding BB prime, right? The second time you reach 16 kilometers over here, and we know these two angles must be the same, right? We know from earlier calculation 63.66. This is 63.66. This is also 63.66. We can find angle BL prime, BLB prime. Yeah, BLB prime is the angle here. So we take 180 minus 63.66 times 2. I've got 52.68. Yeah, this is 52.68. Sorry, a bit small, hard to see. So to find BB prime, I would take use cosine rule. BB prime square, or should I write B prime B square is better. B prime B, so I can put a square here. The two sides are equal. 16 square plus 16 square minus 2, 16 cos 52.68. Okay, use your calculator, square root it straight away. I've got 14.198. Again, textbook rounded off to 14.20. Right. Next, what is the bearing of the lighthouse from the boat when the boat is at the second position? Okay, bearing is very simple in this case. We measure the bearing from north. So basically, we are finding this angle here, right? So we take 180, take 90 plus, yeah, 90 plus the angle between. So your bearing is 90 plus 63.66. I got 153.66. Yeah. Okay. Take note that the answer given in the textbook is 153.36. I don't know. Maybe I made a mistake, but I couldn't find any. But yeah, or could be the textbook made a mistake. Yeah. So I got 153.66. All right. Next question. Now, in this question, you have 4 position of a petrol station, JKLM, yeah, in the district. So you're supposed to calculate, this question I need a lot more space. So A, I'm supposed to calculate the distance JL. Okay, JL is not difficult because you can see from here, this is your triangle. Let's map out all the information. JKL is 44 degree. This is 40. I hope you can see 40, 80. So I know length of 2 sides. I can use cosine rule. Guys, I know this, I know this, I know this. So I use cosine rule. Okay. So 1, 2, 3. So JL square will be 40 square, 80 square minus 2, 40, 80 cos angle between 44. So JL will be 58.277 in kilometer. Okay. Second part, I want to find angle JML. JML is over here, right? I need more information. Let me see. Do I have everything? Yeah, I have. Actually, I can write sine angle JML, right? Actually, JML, KML, they are the same, right? So because they are the same angle here, you divide by the opposite length 80 equals to sine 44 opposite 65 JML. Use your calculator, 58.76. All right, next, Roman 3. I want to find KLM. Sorry, I want to find area triangle. Yeah, but I have triangle KLM. So I need to find angle KLM first, because I know this length, I need to find this angle, right? So to find this angle, I already know these two other angle, right? So okay, let me just label this one more time. It's not difficult. I already know this is 58.76. So angle KLM is 180 minus 44 minus 58.76. This is 71.24. Yeah. If I know this 71.24, I can just use area triangle to be half AB sine C. AB will be 80, 65 sine 70. Okay, I wrote this wrongly. This is 77, 71, 77.24, and I got 2535.76. Yeah, this area in square kilometer. All right, let's look at part B. Without doing calculation, determine petrol station which is the furthest point from, whether the petrol station which is the furthest from point K. Explain. Okay, now when you look at the triangle, you all know about this. Okay, I hope you know, right? When we use sine rule, notice that the ratio of the length A over sine A is the same as B over sine B equals to C over sine C. And also notice that when your angle increases, your sine of your angle increases. So if you have the largest angle, then the opposite length will be largest as well. Now if you look at this, this is your K, this is your M, this is your L, right? You want to find out which one is the furthest from petrol station K. So there is no doubt J is out of question because J is the closest. So it's a matter of whether K to choose M or L, right? Now you look at this angle here, this angle here, and this angle here. This is 44, this is 77.24, this is 58.76. So the largest angle here that we have is angle L, right? If angle L is largest possible, then the opposite side here, KM, will be the largest length of all 3 sides, right? So this is how you explain. Since angle KLM is the largest, right? Therefore, KM is the longest side, and if KM is the longest side, then we say petrol station M is furthest, we should say farthest, yeah, petrol station. Okay, that's how you explain part B. Okay, part C. A car travel along road KL. Calculate the shortest distance of the car from petrol station M. Okay, so now shortest distance from M to line KL is this. So we can use half times base times height, which is area triangle, and compare with the area that we got earlier in A Roman 3. So I use half times base. KL we know is 80. Height I call it H, 2535.79. My H is now 63.395 in kilometer. All right. Okay, let's move on. Next one. So Mary, okay, this one is very long. Okay, Mary color these three triangle, right? Be hard to see, right? And we're given all the measurement. DCE is now 50. This is 50, 50.05, very small, right? So we're supposed to calculate angle CED. CED is over here, so we use sine rule. Sine angle CED divide by the opposite length 7, right, is equals to sine 50.05 opposite length 6.5. Okay, use your calculator. CED, since the question say CED is obvious, I need to take 180 minus, yeah, and in this case I got 124.35. okay, Roman 2, I want to find length of AB. So now let's focus on this triangle here, okay, and because these two are interior, we call it vertically opposite angle, so this is also 50.05. we can use cosine rule. So AB square is 5 square plus 9 square, this is 9, so minus 259 cos angle between 50.05. So AB, I've got 6.943 in cm. Okay, Roman 3, find area of triangle, right? So how to find area of triangle AED? Now, a bit hard to see because of 2-3 triangle involved, but for me, I think it's easier if I find 2 triangle and then I add up, right? Rather than 3 is too long, I have to like calculate a lot more. So maybe I calculate the length of CE first, right? I want to find CE so that I can just add this up, yeah? So I can take this triangle here and then I plus this triangle here, yeah? Triangle ABC, yeah? I'm adding ABC and this whole thing together. The problem is I do not know the length of CE, right? To find CE, I need one angle, okay? So I'm thinking maybe I can find, wait, or you can actually find all three. Sorry, too many lines you can't see. Another way would be I need to find this angle, which I already have. These two angles already have. I already know this angle, but I do not know this angle here. Yeah, maybe I just find angle CDE. That will be easier, right? So angle CDE will be 180 minus, I already know CED, 124.35, sorry, minus 50.05. This is a very small angle, 5.6. Okay, so this is 5.6, right? This angle is 50.05. Now the angle next to it, okay, let me find this angle A. Okay, let me write one more time. Angle ACD is 180 minus 50.05. This is 119.95. Okay, so let's take all three triangle and add up. Yeah, area of all three triangle and we add up. Okay, so the first triangle is triangle, okay, let me write ABC. Second triangle is ACD. Third triangle is CDE. For ABC, I'll take half AB, B is 9, sine angle in between 50.05. Second triangle ACD, half AB is 9 and 7, sine angle in between 119.95. For the third triangle CDE, I'll take half 7, 6.5, angle between 5.6. Okay, use your calculator, work it out. I got 26.368 cm. Oh, very long. Okay. Lastly, yeah, part B. Straight line AB is extended to point F. Okay, maybe I erase this. Too many lines, too many information on the diagram. So AB is extended such that point B prime, such that CB prime equals CB. On the same diagram, draw and color BCD. So if you draw this over here, right, it doesn't look right. It doesn't look very nice. Yeah. And these two will be about the same length. Yeah, it doesn't look very nice because the 5 cm is there. If you 5 cm, I remove it. It is better because these two must look about the same length, right? Maybe I redraw for you. Yeah, I redraw. Yeah, diagram like this. This is a bit too long, so the second one will be extended here. This is over here. All right, this one is over here. Sorry, yeah, my line is not straight at all. So this is ADE 6.5, 7. This is 9. This is C. I'm going to put 5 cm here. This one must look about the same length. Yeah, it must look about the same length as your BC. Yeah, so this is your B prime, this is your B. Yeah, we're supposed to color it, so I'm just gonna color it like that. Okay, so it looks a lot better. All right, and yeah, draw and color triangle BCB. Yeah, this is my BCB. Okay, I think I have one last question to go and we're done. All right, so it's a long practice here. All right, but this is the first part. We don't actually need to use, we are not given angle, we're given a sine of the angle, right? So, okay, now I'm supposed to find sine x, y, yxz, yxz is here. And I'm given sine x, y, w. Now, you know that the angle here and the next angle, yeah, they plus together total is 180. So, and one is acute, the other one is obtuse. And we know by now that if you're given sine x, y, z, x, y, w, sine x, y, z is the same as sine x, y, w. The sine of these two angles are the same. One is obtuse, one is acute, but they have the same sine value, right? So we can write this as 10 over 11. Okay, I want to find sine x, yxz, yxz. I need to divide by the opposite length, which is 4, and take sine x, y, z divided by opposite length, which is 12. Now, this yxz, we can take sine xyz, which is 10 over 11. The 4 I times over, so it's going to look like this, 4 over 12. You can simplify this 1 over 3, so it's 10 over 33. All right, so that's part A. Okay, part B, you're supposed to calculate the area of triangle XYZ, XYZ, and hence find the length. Okay, now we know to find area triangle, I need this angle, right? But to find this angle, I need this angle and this angle. I have the sine value, but I don't know the angle. So let me start by finding angle x. Okay, so from this angle here, let me find, yeah, from this angle here, sine x, y, xz, we can say y, xz, sine inverse 10 over 33, I got 17.64. And from this angle here, from sine x, y, w equals to 10 xyz, I'll take xyz. Xyz is just obtuse, equals to 10 over 11. So angle xyz is 180 minus sine inverse of this 65.38. I got 114.62, right? So if I know these two angles, I know this is 114. Let me just show on the graph. I know this is 114.62. I know this angle is 17.64. So to find this angle yzx, or you can say xzy, I'll just take 180 minus 114.62 minus 114.62 minus 17.64. I've got 47.74. Okay, so if I know this is 47.74, I can just use area triangle half AB sine C. A is 4, B is 12, sine 47.74, and my answer is 17.762, right? This is Kssm squared. And lastly, I need to find the height, yeah, the length of xw. Xw is the height. Now we know there are two ways to find area triangle. Of course, one by using half AB sine C. Again, talk about Heron's law. There's 3. I need to know height here. Yeah, your base is 4 cm. Your height is xw. The result is 17.762, just which is the same as by using half AB sine C. So my xw in this case is 8.8881. All right, this is very long. Okay, next, state the two situations that ambiguous case exists in a triangle here. Okay, now there are actually more. Yeah, can you draw a lot of different types of triangle? But I think the best way, you can see that this is an angle such that the opposite side xy is shorter than another given side. So we say 12. Yeah, 12 is shorter than 12. It can't be shorter than 4. Yeah. So we can either take this, flip it inside, or flip it outside. But obviously here we can't flip inside, so we have to flip this outside. Okay, I'm just going to use a red pen here. I flip it outside here. Okay, so there are two possible triangles I can draw. So the first triangle will be this, right? This is triangle X. I'm going to call this y prime and z. So I think it's better to call it prime each, yeah, so that you can differentiate the triangle. So the second one is this, the without prime, which is x, y, z, yeah, quite clearly shown, right? So now you have to state the two situations. Now the first will be, what can we say? Triangle. Yeah, my first triangle is triangle x prime, y prime, z prime, such that I purposely put prime so it's easier for you to compare and see. They must have two equal sides and one equal angle. So the two equal sides is what? Such that x prime, y prime equals xy, then some more x prime, z prime equals to xz, and angle x prime, z prime, y prime equals to xzy. Can you see? Xzy is here. These two are equal, these two are equal. So this is the first case of ambiguity, right? So now another case of ambiguity is that in order for you to have an opposite side that is shorter, so maybe I pick this 4 cm because 4 cm looks like shortest among these two. So I take this triangle, right? So we either flip inside or flip outside. Now in this case you cannot flip you actually can flip at y, or you can flip at z. Yeah, I actually can flip y outside, or I can flip z inside. Both also applicable. So, but I just want to follow textbook. Textbook, flip it outside, right? So to get another triangle. So let's draw two triangles out. So the first triangle looks like this, right? Okay, I don't have to draw the line here, yeah, so I erase this. The second triangle will be this. Can you see? Yeah, it is the same as this triangle here. You see, it's the same, just that one you flip out, one is flip out, one is flipped in the other direction. So this is your x. I can call it x prime, y prime. So this is y prime, this is z prime, and this is my x, y, z, right? So don't have to label the measurement. Now we know this angle is the same as this angle, right? So the second triangle is triangle x prime, y prime, z prime, such that, okay, you can see in this case which will equal your yz is equals to this yz, y prime, z prime equals to yz. Another one, x prime, z prime equals to xz. Can you see this will equal, and angle y prime, x prime, z prime equals to angle yxz. Yeah, the third angle here is the same as this angle. Alright, this is the end of this mastery practice. I hope by doing this you'll really master this chapter. Alright, so before we go, again, if you are keen to get more material, workbook, modules, that comes with video tutorial. If you like what you see from this video, we have topical practice, drill practice, past year question. You can get in touch with us, call us, WhatsApp us, visit our website to find out more. Also, you can actually you can join our tuition class, or you can purchase this material from our Shopee account. Just go to Shopee and Google Google key in Pusat Tuition Teliti. Yeah, find out more from there. All right, thank you very much, guys. Yeah, hope you enjoyed this video. I'll see you in the